Okay, so I just want to review this first one more time. This is from yesterday. This is the bottom of the lesson yesterday. And so here's the quick summary. If you are asked to find the numbers, find the dimensions, or find the width of a uniform border, those questions that we did, then you're going to end up solving a quadratic equation. So it's going to be equal to something, like they're going to be given the area, it'll be equal to something, you'll end up setting it equal to 0 at some point, almost certainly, and you solve it. And the different ways that we know how to solve things are by factoring or quadratic formula, or in some cases there's other ways, but those are the two common ways with word problems. And the new kinds of questions we've seen are maximum and minimum questions, and it will say that in the question. That's a huge indicator, the key indicator of what you're doing and how you're going to solve this question. So when it says find the maximum, find the minimum, that is different from find the dimensions or find the numbers. Find the maximum. Very different. And in that case, you're completing the square to find the vertex. And then interpreting your answer can be a little bit trickier in that case. So you need to get used to the idea of the vertex is, or part of the vertex is, the solution to your question. So let's take a look at a couple of these examples. Again, this is from yesterday. Two numbers have a difference of 14. A and B, notice the similarities. They both start with two numbers, have a difference of 14. Question A says the sum of their squares is 260. Question B says their sum of the squares is a minimum. So in one question, you are solving, and take a look at what we have here. We have an equation that we can solve when we've subbed in for y. And I can find the values of x that make this true. So that's what we're going to do in that case. We're going to expand, simplify, move everything to one side, set it equal to 0, and in this case, likely factor to solve it. Okay, but when factoring doesn't work, we can always use a quadratic formula. In the case of B, notice what I've done. In fact, this part is the same in both of those questions, because it is the sum of the squares of two numbers that have a difference of 14. That's the similar part. What's different is in A, it says the sum of the squares is 260, and in B, it says the sum of the squares is a minimum. So I just use some variable. In this case, I chose S for sum of the squares, and I find the maximum value of S. This is a little bit tricky, but remember, when I do an equation such as y equals, these are the ones that we did a lot of, -2 bracket x minus 3 squared plus 7, right? So I've got my vertical stretch compression and my reflection. I've got my horizontal shift and my vertical shift. And so I see that. Okay, so in this case, this is my y, and that's the y that's minimized. If I look at the range of this parabola, y will always be greater than or equal to something that has a minimum, and so that's what we're finding. And in this case, we looked at the possible pairs of numbers that have a difference of 14. It wasn't this example, but there are lots of pairs of numbers, infinite pairs of numbers that have a difference of 14. But in one case, there will be a minimum value of the sum of the squares, and that's what we're trying to find. So we end up completing the squares you've seen I've already done here, and finding the vertex. And in this case, the 98 is the minimum sum, but that's not important. We don't need that as part of our answer. The question could have asked for that, but it didn't in this case. It just asked for the numbers, and so one of those numbers is 7, and then I could find the other number with my little mini equation that I've got up here. Okay, so that's one type. Height of the rocket. Again, I'm given the equation, but these are the questions here that will define how I solve them. So what is the maximum height? There's the key indicator that in this case, maximum occurs at the vertex, so I have to complete the square in order to find the vertex. When does the max height occur? Same thing. That's just the x value of the vertex. So when I find the vertex, I'll know the answer to both questions 1 and 2. When does the rocket hit the ground? That's there. So in this case, you are solving and using one of the strategies or skills you have to solve an equation. When it hits the ground, in this case, that's where height is equal to 0. So I solve for when the equation that we were given is equal to 0. And the last couple of examples here, so again, I'm given the area, so I will end up solving. And this one asks about a maximum area. This is a type of question we haven't seen yet. We're going to look at that in a few moments. Maximum area. And in this case, we will be completing the square to find the vertex, not solving. Solving won't help us in this case. So that's a quick review of the different kinds of questions. Let's take a look at today's lesson. Again, we're given the equation in this case. So this is the type where it really can be helpful to draw it and think about the different value, or think about the different properties of a parabola. What's important? Okay, so this is a paper airplane thrown off a hill, and h is the height of the plane above ground in meters. D is the horizontal distance the plane has traveled. A little bit different from yesterday where it was with the time taken. This is the horizontal distance. So question A, determine the maximum height. Well, we just finished talking about this. How am I going to find the maximum height? I'm going to complete the square to find the vertex. So I'm going to start with this. And I'm going to go ahead and complete the square in order to solve this question, this problem. So I'm not going to solve the quadratic. I'm going to solve the question, is what I mean by that. So let's start doing this. Negative 2.18 bracket. So I'm going to end up with d squared here. And I'm going to need to divide with my calculator. Okay, and that one worked out as well, so it ended up being negative 2d. Divide that by 2, square it, so that's plus 1 and minus 1. And then plus 32.82 on the end. Negative 2.18. So d minus 1 squared. Whoop, sorry, I'm skipping a step here. I'll go back. Do this properly. D squared minus 2d plus 1. And then negative 2.18 times negative 1 is plus 2.18 plus 32.82. Okay, and now I can finish this. Okay, so d minus 1 squared. And I do believe 2.18 plus 32.82 is going to give me a nice number of 35. Whenever I finish these, I always write the vertex, remind myself what I'm doing. And this is the tricky part, but this is where the thinking, the understanding, and really that I think people skip, but it's helpful to take the time and think about what this means. So this is a value of d, and this is a value of h. It's an ordered pair. And that was like my x and my y compared to an equation that we're used to graphing, right? So it's like my x, y coordinate, but in this case it's d and h. So d is a distance and h is a height. And so what is this saying? It's saying that the maximum height occurred after 1 meter, and the maximum height was 35 meters. I'm getting the impression this wasn't a very good paper airplane. Okay, so the question we're asked is determine the maximum height the plane reaches. Therefore, the plane reaches a max height of 35 meters. So the plane reaches a max height of 35 meters. B. what is the plane's horizontal distance when it reaches maximum height? So we've already done all the work, but again, this is, I didn't graph this one, I should have, sorry. Should have sketched this. So it looks like this one kind of does something like that. Okay, so there's my 1, and there's my 35. And that's from the vertex. And so what horizontal distance when it reaches the maximum height is that right there. So the plane travels 1 meter to the max height. Not always ask both those questions, but you notice that often we do get both of those. And in this case, we certainly did. Okay, and C, what horizontal distance from where the plane was thrown will it hit the ground? So that question is asking about this distance until it gets to here, where it hits the ground. So this is the kind where we are going to solve. So we're going to so H will be 0. Whoops, not T. So let me start with H equals 0. Find D. Okay, so here we go. 0 equals negative 2.18 D squared plus 4.36 D plus 32.82. And you could try dividing through by negative 2.18 and see if that gives you something nice. It's possible that this is factorable, but usually in these cases we use the quadratic formula. So I'm going to leave that. I think people know how to use the quadratic formula. The solution will be done and will be posted to the classroom so you can see it after. But for now, I don't think you need to watch that. We'll do the same thing. We'll just set this one up, and the solution will get posted afterwards. But it's the same idea. So in this case, we need to define our variables first. So let's see, we have the base and the height. Let B represent the base, the length of the base. And let H represent the height. Height is a length by definition, so I don't have to say the length of the height. Okay, so determine the max. So determine the maximum. So it doesn't actually, it says the sum of the base and the height is 12. Yes, so I do need that part. So base plus height is 12. And so I could rearrange this however I want. I'll say, so the height is equal to 12 minus the base. Okay, and so I'm going to have to come up with my formula here. Area equals 1/2 base times height. That's the area of a triangle. Formula for area of a triangle. This is a little bit trickier because of that 1/2. And area is what is going to be maximized. So I'm not subbing in for area. I'm not given the area. I'm completing the square. In this case, I'm finding the vertex. So 1/2 base times height, which is 12 minus the base. And that 1/2, I can actually, because I'm completing the square, I can just leave it out front. This is a little bit tricky. I think it would trip some people up. So I'll start with this step. So 1/2 bracket negative b squared plus 12b. So I just multiplied the b into the brackets. I rearranged there a little bit as well. And you can see this is what I would have to do to complete the square anyway. I have to pull out the negative as well. So we'll do that. And then I'll show the rest of the solution just online. But I'm going to continue by completing the square here and finding the vertex, and that's going to give me the maximum area of a triangle that has a base and height that adds to 12. So there would be an infinite number Not, I guess some of them wouldn't work because they'd be negative, but mathematically there'd be an infinite number, pairs of numbers that add to 12, right? The sum of lots of numbers is 12. 1012 and negative 1000 add to 12, right? So there's lots of numbers that do, but we're looking for the maximum pair that satisfies that formula. Okay, and the last one, this one's a little bit of a new one, so we'll spend a bit more time on this one. Okay, so what are the dimensions of the maximum area Randy can enclose? So we're looking for dimensions here. But so I'll start with that and get that out of the way. Let L represent the length, and let W represent the width. Okay, and I'm going to draw this. So let's see. He has a warehouse or a barn or something like that. Often it's a barn. It's a farmer with a barn. So there's the warehouse. Okay, and he's putting a fence up against it. And we want to know the maximum area that you can create when you have 120 meters of fencing that you can use to create that. Okay, so this is a little bit different from the questions that we've seen again because it's up against a house. And so what I have here, and this is how I like to do these, I have one length and I have two widths. And so those length plus two widths has to add up to 120 meters, right? And usually it would be a perimeter formula, but this one is a little bit different. And if you draw the formula and you just label the lengths and the widths, you can use that. You just know how many you have, because sometimes this is a common problem where I have three sides, but there are different kinds. And I end up with length equals 120 minus 2w, right? And that should be familiar. We know that. Now we're looking for maximum, so we're not solving this, but that should be familiar. So again, I get area equals length times width. And so area equals length, which is 120 minus 2w times the width. So that's 120w minus 2w squared. And if I just quickly rearrange that, negative 2w squared plus 120w. Okay, so let's complete the square here. Minus 60w. Half of 60 is 30. Squared is 900. Add and subtract that. And then 900 times 2 is 1800. Notice how when it's a maximum question, I get this question often. How do I maximize it compared to minimize it? How do I know which one I'm doing? You don't have to worry about that. The math will always figure that out. The question is designed in a way where it has either a maximum or a minimum, not both. And you'll notice when you ask for when you're asked for a maximum, that you end up with this negative out front, and this is a parabola that opens downwards, so it has a maximum. And if you're looking for a minimum, you'll notice that the leading coefficient will be positive, and so the parabola opens upwards, and it will have a minimum value. Okay, and so this is minus 30 all squared plus 1800. And so again, my vertex is 30 and 1800. And what does this mean? Well, this is my width, right? And this is my area. So the maximum area turns out to be 1800, but it occurs when I have a width of 30. And I can, if my width is 30, then my length is 120 minus 2 times 30, which is 120 minus 60, which is 60. So there's my dimensions. Therefore, the dimensions are 30 meters by 60 meters. And if you do that on a calculator, the area of 30 by 60 is 1800. So there's your maximum area. And that could be a little check to make sure that that makes sense. And you could try another set of numbers in here. Like what would be another one that would work? If I made W 10, then I had to have 20 here, and my length would have to be 100. And 100 times 10 is 1,000, which is less than 1,800, right? So I'm looking for a bigger area. He wants to maximize the yard space in this case. So 1,800 is bigger, so that would be better, I suppose, in this case. Okay, so those were 3 maximizing questions. The first one had a little bit of a different example as well. 3 maximizing questions were completing the square, finding the vertex in each of those cases. Like I say, you can find the full solution online, but make sure you understand the different types of equations. That's a big part of the work in this unit.